the webinar is about the installation of and the quick start of Galera Cluster. Let me, before I go and give the microphone to Philip Stoev, who will go to the actual explanation of the installation and the quick start. Let me just quickly go through a couple of things about Codership. By the way, I'm hoping that you are hearing me well. You are all muted during this conference, but later on we can answer your questions when you put your question to the question chat box, and we try to address all of your questions. This webinar will be recorded also, and we will give you the link to the webinar also later on. But about Codership, we started Galera replication development already 2007. And I think it was 2009 when we first launched first production version of Galera. So it has been on the marketplace for quite a long time already. The basics of an architecture and the design of the Galera is developed by three co-founders, Seppo, Teemu, and Alexei, who already have made three other MySQL cluster software products before they started Galera development. So they had a pretty good understanding what needs to be done, what is required by the customers, and how can we actually make a better solution compared to, for example, master-slave replication by Oracle and MySQL. The product itself and Galera is based on really sound academic theory, and we have used some research work of people to make it really good product and had a really good basics behind it. The product itself is called Galera Cluster for MySQL. It's open source product. You can download it from galeracluster.com freely, use it freely. And our business model is to sell support and consulting to our users. Today, there are thousands of companies using Galera already. They are giant e-commerce sites like Mercado Libre, which is 8th biggest e-commerce site in the world. It's called the eBay of South America, and they have almost like 100 million users there. Galera is being used there with the OpenStack, storing OpenStack metadata. And they have a 9-node Galera cluster split to 3 geographical locations. But there are many other users and different kind of segments. Wherever the high availability is needed and scalability is needed, Galera Cluster is the most robust solution for MySQL users. Galera Cluster is also included and will be included in Linux distros and OpenStack distros. For example, at the moment there is a progress with Debian team and the project team to include Galera into the Debian. There are 3 Galera variants in the marketplace. First of all, there is Galera Cluster for MySQL, which is developed by Codership. Then there is MariaDB Enterprise Cluster, and then there is a Percona XtraDB cluster. All of these are based on our Galera Cluster replication. We built MySQL API and make the Galera replication blocking to able to hook the MySQL, and we give this version to Percona and MariaDB, and they merge these to their own MySQL variants, MariaDB and Percona, and this is what you can see in the marketplace, and you can download their versions of software from their websites. So this is the background information. I don't want to go any deeper what's going on Codership, what's happening, and I give the mic to Philip Stoev now for the presentation. Wait a second.
Hello everyone. My name is Philip Stoev and I will be hosting today's webinar. And the topic is, as Sakari already mentioned, the installation of Galera Cluster and how to start using the product. We are going to have first some demonstrations along the way. So the agenda for today is I will give a very quick overview of Galera Cluster. Then we will cover how to add our Galera package repository to your system so that you don't have to download any packages manually in order to install Galera Cluster. We will cover the installation of the packages and how to create the most basic configuration file, and then how to bootstrap a 3-node cluster. Once we have the cluster running, we will see how you can monitor it using readily available tools. I hope that even people who have already installed the product will find some useful information along the way. So first, a very quick overview. Galera Cluster is a synchronous multi-master replication solution for MySQL. Synchronous meaning that each transaction is immediately replicated on all the nodes at commit time. So there is no concept of slave lag, and the system takes care that all the nodes are kept up to date and that no node falls far behind the others. It is multi-master because every node from the cluster can accept both reads and writes. And Galera takes care of resolving any transaction conflicts in case conflicting transactions have been issued simultaneously on different nodes. This situation will be detected, and one of the transactions will be aborted so that the data remains consistent across the cluster at all times. It is a replication-based solution in a sense that the entire data set is available on all the nodes. No sharding takes place, and all the replication is taken care of internally, including when a new node is added to the cluster, it is automatically synchronized with the existing nodes so that there are no manual operations like taking a snapshot or figuring out what is the current position of the master or the current position of the slave. There is no need to run any SQL commands to synchronize things at startup. And as Zachary mentioned, it is a modified version of MySQL. We provide binaries for 5.5, 5.6, and we have 5.7 coming up. And it is based on the DynaDB storage engine. It is the DynaDB storage engine that is used to store the actual data and to answer the actual queries. So all the tuning that is done for DynaDB applies 100% to Galera. All the knowledge that you guys may have about DynaDB and how it behaves, how it performs, is immediately applicable to Galera Cluster as well. And the product has a lot more features that make life easier for database professionals, especially if there is a node failure, the cluster will detect the situation and recover within seconds. There is no need for third-party monitoring processes to watch out for the health of the cluster nodes and take nodes out or bring nodes back in. There is no need to switch the master from one node to the other using a third-party solution. There is no need to promote slaves to masters and things like that. All of this is handled internally in the product, with the exception of load balancing the actual queries. Galera Cluster offers very strong data consistency protections. You're prevented from reading very stale data, and you're prevented from making unsafe modifications to the data, as we'll see later in this presentation. Furthermore, the product has very good support for wide area networks. It is possible to have multiple nodes on multiple different data centers, countries, or continents. And this is, as Sakari mentioned, a configuration that is widely used in production, and it is known to work. We offer end-to-end encryption for this scenario. And most importantly, Galera, the protocol, the replication protocol, the entire method of operation is optimized so that at least the latency penalty is incurred if a wide area network is used. Even though some latency is unavoidable due to the speed of light, the protocol is such that only the smallest amount of latency is needed to ensure consistency across the servers. And when you commit a transaction, it is replicated in the most efficient way to all the nodes, regardless of where they are. Okay, so the first part from getting started with Galera is to install the required packages. Step one would be to remove on the machine that you're using any existing MySQL Server packages and shut down any existing MySQL servers. And then we'll add the Galera Cluster repository, which is basically an instruction for your package manager that it should find the Galera packages at a certain location on the internet. So here we have a virtual machine that is a pristine installation of CentOS 7, and we are going to see how to add the package, the repository for CentOS 7. The instructions are slightly different for SUSE and for Ubuntu and Debian, but our documentation, which you can find on our website galeracluster.com, has specific instructions for each one of those distros. For CentOS 7 in particular, we go to the /etc/yum.repos.d directory, and there we simply create a file that is called Galera repo, and there we need to add the stuff that you see on your screens. Add those lines. This first line is an instruction on where to find the packages, and the second line is the location of our public key that is used to authenticate the packages. Okay, so now that we have those lines in this file, then we are ready to actually start installing the packages. And the first step would be to replace some MySQL libraries that ship with CentOS 7 and replace them with Galera compatible versions. So the first step would be to run this command, yum upgrade so to be sudo. Okay, so now what we see is that your package manager automatically retrieved the package information from the repository, and the package can now be installed as if it is a package available from your distro. There was no downloading involved, except that I need to fix this URL. Okay, now much better. So now we have installed this library package that is needed to satisfy certain dependencies. This is only needed for CentOS and Red Hat based systems. For Ubuntu, the packages for Galera can be installed directly. And now that we have prepared the system, we can actually install the packages that are needed. The first package that is mentioned here, Galera 3, is the one that contains the actual replication plugin, and the second package contains the actual modified MySQL server that is used to run Galera. So with this, we can see that it is going to automatically install all dependencies and begin quite a lengthy download. So rather than wait for it to finish, we are going to use for the rest of the presentation a virtual machine that already has those packages installed. But as you saw, the process is fairly straightforward. Okay, the next step is to prepare your system for Galera installation. We recommend that when you do a Galera evaluation that you use nodes or virtual machines that have identical hardware. The reason for that is that in Galera cluster, each node commits each transaction that is issued to the cluster. So all the nodes should be equally capable of keeping up with the workload. And if you intend to run benchmarks or real-life applications against the cluster that you're installing, it is good to have sufficiently powerful virtual machines. Do not go with like a 64 megabyte memory virtual machine. Do not go with the cheapest option from your virtual machine provider. Do not go with the smallest EC2 offering, for example. And make sure that all the nodes are identical to get the best experience from the system. Galera cluster requires that 4 different ports are open on your firewall. You may find it easier to disable the firewall altogether for evaluation purposes. If this is not an option, then you should make sure that those ports are open in both directions, meaning that each node should be able to contact every other node on those ports, because in a cluster you never know which node would want to establish a connection with another one. And network issues that are caused by asymmetric firewalls are generally fairly difficult to debug. And finally, you should disable Linux, and then it is possible to enable it in logging mode and finally create a policy and enable it later. But for installation purposes and for quick start purposes, Linux should be disabled, otherwise it would not be possible to start the cluster properly. Then we need a my.cnf configuration file. All the configuration for Galera cluster is stored in the my.cnf file along with the rest of your usual MySQL options. There are no separate files or file locations to think about, which simplifies management quite a bit. And we recommend very strongly that you keep the my.cnf files on all the nodes identical, because if you are tempted to edit one of the files and not the others, you may see behavior in the cluster that is difficult to explain. If you can also use an automation solution to keep the files identical and to store them in a central location, for example. When preparing the my.cnf file, you should note that it is the InnoDB storage engine that is storing your data and answering your queries at all times. Galera takes care of the replication part, but for performance purposes, for optimization, it is very important to have web optimized MySQL standalone MySQL configuration, meaning especially give InnoDB plenty of memory, especially again if you want to run any benchmarks or any real-life applications. You should do them. You should do that on a Galera cluster where the InnoDB part has been optimized properly. And finally, we have the Galera specific settings that we are going to talk about in just a bit. And we need to put those into the my.cnf file as well. And now I'm going to do that on one of the virtual machines that I have. So basically, this machine is again CentOS 7, where those packages that we saw earlier have already been installed. And as you can see, we don't have any MySQL processes running here. The MySQL is not started when you install the package because we need to add those additional configuration lines first, and then we will be able to start our first node. So here we see that the lines have already been added for convenience, and the meaning of those lines is as follows. So first we have default storage engine equals InnoDB. In a Galera cluster, it is very highly recommended that all the tables are in the InnoDB format, use the InnoDB storage engine. By default, Galera cluster will not replicate my ISAM tables or NDB or any of the other engine types. So by specifying this in the configuration file, you force future tables that are created without an engine specifier to use InnoDB. And later we will see how to check your cluster for older tables that are not InnoDB. The next line that we have here is binlog format. Binlog format needs to be raw for Galera because Galera replicates raw-based events, meaning that unlike statement-based replication, when you issue a query on one of the nodes, it is the updates that this query made, that this transaction made, that will be replicated to the other nodes in the cluster. It will not be your actual insert or update statement that you ran, but the effects from the statement. What is important to note here is that by default, Galera does not require the binary log itself to be enabled as a file on disk. You can certainly enable the binary log to be written to disk if you need it for backup purposes or for integration with traditional MySQL asynchronous replication. But Galera runs just fine without writing the log to disk. Those replication events are generated for every transaction that you run, but they are not recorded in the file. They are simply replicated across the network to the other nodes. Then we have this InnoDB autoinc lock mode equals 2. This is an important setting if you're running auto-increment queries, if you're running inserts into a table that has an auto-increment field. This setting needs to be set to 2. And then we have the reset provider. This is the location of the replication library that we installed previously as part of this Galera 3 package. The location of the library is distribution specific. For CentOS 7, it is located at this path, but in other distributions, you may find that it is directly in user /lib64 without this Galera 3 subdirectory. And finally, and most interestingly, we have the recipe cluster address setting, which is basically a comma-separated list of all the nodes that participate in this cluster. In our case, we will start a 3-node cluster. I have entered here the IPs of the 3 nodes that I will be using. You can also use host names here, and it is recommended to keep this string up to date and identical on all your nodes. So, for example, if you add another node, then for consistency purposes, it is good to update the string on all your nodes, including the ones that existed previously. Okay, so now that we have this, we are ready to start our first node. You will see here that there are no InnoDB specific settings in my .cnf file, but as I mentioned previously, they are very important when actually evaluating the product for performance or with a real application. Okay, so now we are ready to start our first node. Starting a cluster for the first time is called bootstrapping. And the special thing here is that the first node needs to be started in a slightly special way so that the system knows that a new cluster is being started, and this is the first node from this new cluster. So what we do here is we use the standard service MySQL start command, but we add this -- reset new cluster option, which basically instructs this node to consider itself the first node from a newly created cluster. So when we do this, we see the usual starting MySQL prompt, and then we are able to log in into that node. So for the purpose, I'm going to go root. And then on this particular distribution, the MySQL root password has been automatically generated at installation time and is placed in this file. But depending on your distribution, when you install the package, it may prompt you to enter a password at installation time. So let me log in with this password. And you see it's a normal MySQL server. Our first order of business is to change this password to something much less secure. And once we have that, we can look around and see how things are going. So the usual way to examine the status of the Galera cluster is to use show status. There are a lot of status variables, and they are all prefixed by this WSRIP prefix, and we will examine the most important ones over the course of this presentation. As you can see, there are quite a few of those, so not all of them are important right now. What is important is this one, recipe cluster size, which tells us that this node is now a cluster of its own with a size of 1. So we are doing good so far. Now what we can do here is create some tables and insert some data into it. As you can see, so far it behaves like a normal MySQL server, and if we do show create table on this table that we just created, we see that it has been created with an InnoDB storage engine, which is what we were after. So now that we have that, it is time to add our second node. So we are going to switch to another virtual machine, and there we can start our second node, and you will see how the two nodes will connect to each other automatically, and how the cluster will start having two nodes. So let's So give it a second for my DNS to not do its job. Okay. So this is our second node. Again, we can see here that we have the my.cnf file as before, and that the contents of those files are the same. And so what we can do here is simply start the MySQL service. Since this is our second node, we are not using any additional options. We are not specifying that this node is anything special. We just do it like this, and it is going to start. What happens right now in the background is that the two nodes connect to each other, they form a cluster, and our second node will fetch automatically the initial snapshot of the database as it existed on the first node. So again, this happens behind the scenes. There is no need to ship any files, any data files between the nodes. It all happens internally. So now what we can do is log in into our second node, and note that here I'm using the password that I already changed on the first node. As part of this initial transfer of the entire database snapshot, the passwords and users and everything from the first node were copied over to the second one. And I am in, and now if I do this show status command again, we will see that now it reports that the cluster has two nodes. And furthermore, if I go to my table that I just created on the first node, we will see that this table is now on the second node, and the two nodes have identical data. So now if I do an insert here, I can immediately go back to the first node, and the data is there. So replication has been established and is now taking place. So we can do the same for our third node. And again, after waiting for my DNS, by simply starting the MySQL service with the proper configuration file, this third node is going to join to the first two ones, and the cluster will now have 3 nodes. It is recommended to have an odd number of nodes in your cluster, 3 or 5, in order to prevent a problem called the split brain, meaning that if you only have 2 nodes and the network connection between the two of them gets disrupted, then neither node is in the majority, so to speak. Neither node can safely perform updates because it has lost the connection to the other half of the cluster. And both nodes will then refuse to accept queries. With a 3-node cluster, if one of the nodes is disconnected, as we will see later in the presentation, the other 2 nodes can safely continue to process updates. So here on our third node, we simply do again MySQL service start, and that's it. And after waiting for the initial synchronization to take place, we can immediately see that the cluster size is now 3, and our data, as it existed on the other nodes, is now also available on the third node. That's it. Those were the only commands that were needed to establish a fully working 3-node database cluster. Okay, now that we have our cluster, I'm going to talk a little bit about how to monitor the cluster. Since it is the entire operation of Galera happens inside MySQL, you should be using the usual methods for monitoring MySQL that you already use, with the addition that the Galera now exposes a few more variables, a few more status variables so that you can monitor. but otherwise your existing tools should be sufficient. There are no additional clients needed to fetch status information from the cluster. There are no separate log files to read or parse. So first, we're going to see what we need to monitor and show variables. So the variables to be monitored can roughly be separated into two categories. One, some report the actual health of the cluster and the individual nodes, and some other status variables report the health of the replication between those nodes, whether there are any delays, any bottlenecks. So you should be monitoring both of those. The first one that is listed here is recipe ready. It should always be show a value of on. It indicates that this the Galera replication library has been properly loaded and that the cluster is sufficiently configured. Even though it may not be fully connected, at least when recipe ready is on, you know that on the most basic level, the node is ready to replicate. Then we have recipe cluster size that we already saw, which indicates the current number of operational nodes in the cluster. If you have an automatic monitoring solution with alerts, you may wish to set an alert that will fire every time a recipe cluster size decreases or drops below a certain value that you find acceptable. For example, if you have a 5-node cluster, but you can tolerate working only with 3 nodes for redundancy purposes, then you can set an alert accordingly. The next one is recipe cluster status. This variable should have a value of primary, meaning that the particular node where you're doing this show status is part of the cluster and is able to operate and to receive updates. So now I'm going to make a quick demonstration using virtual machine VMware technology. So for example, consider this case. On our third node, we experience a network failure. So I'm going to disconnect the network adapter here altogether. And let's see what happens. First of all, let me log in using this console because I no longer have SSH connection to this node. So if we go here, see, the status has changed from primary to non-primary. This means that this node has automatically detected that it has been separated from the cluster for one reason or another, and now this is reflected in the status. And furthermore, since this node is no longer current with the rest of the cluster, it actively refuses to answer any queries. So you get this error when you try to select from the database. Getting this error also instructs your application or load balancer that this node is no longer good for the time being, so your queries should be directed to another node. So now that we have that, we can see that if we restore the network connection as it was before, after a couple of seconds, the node will reconnect to its peers, and now recipe cluster status shows a value of primary, and it is now possible to run queries once more. The final variable of interest in this group is recipe local status. It should be synced. The value should be synced for all nodes that are not joining the cluster right now or providing the initial snapshot for another node that is trying to join the cluster. So if you see if a new node is joining the cluster, its reciprocal status value may be different, but eventually all the nodes should go back to this value of synced, which indicates that they are fully up to date with their peers and they can answer queries. Then we have the group of status variables that denote the health of the replication itself and whether there are any bottlenecks in it. And here there are two concepts that are important. First is the so-called flow control, meaning that in order for the cluster to move forward as a whole, no node should be falling too much behind the rest of the nodes. As mentioned previously, one of the goals for Galera is to prevent slave lag. So every time Galera detects that a particular node cannot keep up with the transactions that come from the other nodes and cannot commit them, it will throttle the entire cluster until this slower node is able to catch up. When this happens, you will see that this value recipe flow control post is going to increase, and it is recommended that it never goes beyond 0.05, meaning 5% of the time. If your cluster needs to throttle itself more often than that, there is a performance problem that needs to be examined. And it is so important to keep the nodes in identical configuration in order to avoid a particular node persistently being slower than the others, because this flow control is then going to kick in very often and you will see this value go much higher than that. The other two status variables that are important to monitor with respect to the health of the cluster overall are recep local BF aborts and recep local cert failures. Those variables increase every time there is a transaction conflict, meaning every time transactions were issued on two nodes, but they were in conflict, contradictory to one another, so Galera could only allow one of the transactions to proceed. Every time this happens, the client will get back a deadlock error, and those counters, one or the other, will be incremented. And if you monitor those counters on all of your nodes, you should be able to see how many transactions fail because they conflicted with some other transaction. If those numbers are very high, then obviously quite a lot of the transactions that you're issuing are failing and need to be retried, which in turn impacts performance. It impacts the overall operation of your applications. So if you see any of those counters increasing, then you should consider either rearranging the transactions so that they don't conflict that much by, for example, issuing all the transactions that could potentially conflict to a single node. If you do that, then there will be no possibility for a conflict between the nodes. And the overall operation of the application will be smoother. And since those are counters, if you do flush status, they will be reset and they will start to accumulate anew. So it is advisable to do this periodically if you collect this information, if you graph it, or if you're making any decisions based on, for example, the current state of the cluster, you should issue flush status so that any data that applies to a time in the past does not impact your current observations. Then we have the other usual thing that DBAs monitor, show process list. Galera does all of this replication work at the end of the transaction. So in show process list, you may see queries that are in the state of query end. This is where the updates that the query made or the transaction made are replicated to all the other nodes, and all the other nodes agree that this transaction is good and can move forward. Especially if you have a wide area network, this time can be impacted by latency. So if you see a lot of queries that are spending a disproportionate amount of time in this phase, then some action may be needed to optimize the system. Another thing that you should watch out for are long-running DDL statements. Under the default setting, issuing a very long-running DDL statement may block all the other statements or all the other transactions on the cluster. So if you observe such statements or if you intend to run such statements, then please check the documentation for a way to work around this situation. And finally, we have some useful queries for you from the information schema. Basically, Galera does not have its own tables in the information schema, but those are useful queries nevertheless. The first one will list any tables on your machine, on your system that are not InnoDB tables. So especially if third-party users or third-party applications are allowed to create tables on your system, you may wish to run this query periodically in order to detect any situations where MyISAM is used, for example. And the second query lists all the tables that have no primary key. In order for Galera replication to be efficient, each table should have a primary key. Unless it is a very small, very infrequently used table, each table should have a primary key, because otherwise updating such tables will cause performance issues in the cluster if each row of the table does not have a unique identifier. So with this monitoring query, you can see if any such tables have appeared on your server, and then take some action to add a primary key or otherwise remedy the situation. Okay, and that completes the demonstration. Please feel free to use the chat box on your GoToWebinar control panel. On your screen, you should have an orange arrow at the top right corner of the screen. If you click the arrow, a chat box should appear, and please type your question in there, and we will answer it to the best of our abilities. Okay, so we have quite a few questions accumulated already. Let me answer them in the order that they were posted. So first, will the recording be available to us later? Yes, we intend to upload the recording to YouTube, and we will try to also post the slides. The second question is, can you install Galera by installing the 2 Debian packages if you don't have access to the public repository? Does the plugin work with Oracle Enterprise? The first question, yes, you can manually download the packages from our website and install them manually if you do not want to have access from your server to the public repository. On the second question, we support only Oracle Community Edition, Percona XtraDB cluster, and MariaDB cluster. We do not support Oracle Enterprise. Even though you could download the source code from Oracle, apply the patch that gives you Galera functionality, and compile the binary yourself. Second question. With respect to snapshots, The question is whether Galera copies the entire database or just any differences between the nodes. So if a node is starting with no data whatsoever, then of course a complete copy of the database is shipped from what we call the donor node to the new node, which we call the joiner node. If, however, the joiner node was only down for a while, Galera attempts to apply an optimization where only the updates that happened on the cluster while the node was down are sent to it to be applied to the database rather than copying the entire database. There is a parameter, it is called the Gcache size, that defines how many megabytes of data Galera will be saving for the purpose of providing such incremental, as we call them, incremental state transfers. If you want to avoid shipping the entire database every time you have an extended server downtime, you can increase the value of this parameter, and this will increase the chance that Galera will decide to only ship the difference between the two nodes. Next question is, how is the copying done? Copying, we provide different mechanisms. Copying of the data, initial copying of the data can happen via rsync, via MySQL dump, or via taking an extra backup, shipping it over, and then restoring the backup on the new node. Each of those methods has different benefits or downsides, but it is possible for the source server to continue running during this transfer if, for example, the extra backup option is used. Because extra backup is a non-blocking backup, it is possible to take it while the node is running. Next question. Can we show the my.cnf on all three machines? Yes, I can do that. The node is, let me show my screen once more. The my.cnf file is very straightforward. Of course, all the other things that you may wish to add that are performance related, you're welcome to do that. Just a second. Here is the my.cnf file that I used. The rest of the stuff that you saw in there came from the distribution. So it was the default my.cnf for CentOS 7, and then I added the lines that are listed here, and that was it. I didn't do any other modifications. Okay. Let me continue with the questions. If the binary logs are not in use, how it knows what is the diff between the nodes when you join a new node to the cluster? Galera keeps the required information in a separate file on its own that contains the required updates that happened on the machine. So it is not the usual binary log, but it is a separate file that is only used in Galera. And Galera takes care of managing that file and cleaning it up, so you don't have to do anything about it. You can still use the usual MySQL binary logs for backup purposes and things like that if you need it. Next question. In a two-machine cluster, no node accepts inserts in case of split brain. Is that configurable? Yes, there is a sort of hidden option that allows you, when you have two nodes and they lose connectivity with each other, there is an option that will allow both nodes to continue to accept updates, even though this is unsafe. And when the two nodes rejoin, it is a big question as to how those now two diverged servers will be able to reconcile. So this option should only be used if you only send updates to one of the nodes in case of a split brain. Sending updates to both nodes while they have no connection with each other is not supported, and there is no guarantee as to what is going to happen. Next question, what happens if the first node that was started goes down? You just restart it the way you normally do, and that's it. You don't even have to specify this reset new cluster option. You just restart the node, and since it has in its configuration file the list of all the other nodes, it is going to connect to them, and the cluster is going to be reestablished. Next question. Does Galera have any connector that our app can use for automatic failover? At Galera, we do not endorse a particular load balancing solution, but I know for a fact that some connectors allow you to specify multiple servers when you initialize your connection. So in some MySQL connectors, there is this option for the connector itself to try another server if the first goes down. The other option would be to use a third-party load balancer that will make this decision for you. The important thing is that with Galera, every node can accept any type of query. So the logic for failover is vastly simplified on the application side. You don't have to keep track of which server is currently the master because each Galera node is a master. Are there any open source paid GUIs GUI tools for monitoring cluster performance? Yes, you may wish to try a tool called Cluster Control by Several Nines. And you may also wish to try Moniok, which is a fairly popular tool for monitoring MySQL. They have recently added some features that monitor those Galera variables, status variables that I just talked about, and you can get nice graphs and alerts and things like that. Okay, how can I synchronize the Debian MySQL user between the nodes? What Galera will do for you is synchronize only the contents of the database. So synchronizing your configuration in the operating system is not something that Galera will currently do for you. When you create a new user, we would be replicated to all the nodes. Yes, all those commands such as create user, drop user, create table, alter table, those commands are all replicated. So if you create a user using create user, it will be created on all the nodes. An exception of this is if you create the user by directly inserting rows into the MySQL schema and the users table in it. If you do that, then this will not get replicated by default. It is better to use dedicated syntax for creating users, such as create user. Insert update delete is replicated synchronously. So if there are more nodes, the weather performance will decrease if there are more nodes. Well, not really, because if all the nodes are well behaved, if all the nodes can keep up with the cluster, then you can have many nodes, and they will all your transactions will be sent to all of those nodes concurrently. So there is no reason for the performance to decrease if you add more nodes. Of course, if you add more load and more queries, then performance may suffer because of that. The user is asking how is password update replicated if the MySQL.user table is a MySM table. If you use dedicated statements for managing your users, then those statements are replicated even though the underlying MySQL.user table may be a MySM table. Next question. Do I need to backup all the nodes, or it's enough to backup only one? It is enough to backup only one node because all the nodes contain exactly the same copy of the database. So you can focus your backup efforts on a single node, and it is even possible to have a dedicated node just for backup purposes. It is even possible for this dedicated node to only run while you're taking the backup rather than at all times. How should clients distribute their statements over the nodes? It's a good question. The idea is to avoid having conflicts between your statements that involve more than one node. For example, if you issue an update on one node and then a conflicting update on the other node, this conflict will be detected at commit time when those transactions attempt to replicate. It is better to direct such conflicting statements to a single node in first place so that this conflict is resolved within the node. But apart from that, you're welcome to distribute the statements in any way you see fit. Some people use Galera in a master-slave mode where all the updates are signed to a single node and the other nodes are used just for reading. This works just as fine. If it simplifies your deployment, if it makes it easier to port your existing applications, you could do that as well. Does Galera have any connector that our app can use for automatic failover? As I said, we do not provide our own connectors, but some of the existing MySQL connectors have some limited failover capability built in them, where you can ask the connector to connect to a list of servers and pick the first one that works. When I need to scale the server, do I have to restart the whole nodes or it is dynamically updated? No, you don't have to restart the whole cluster. You can just add your additional nodes and they will join the cluster. The only thing that we recommend is to update your my.cmf file on all the nodes to keep it current, but you don't have to restart the existing nodes right away because they will already know about your new node and the nodes will find each other without restarts. Okay, so I think those were the questions that we had so far. So thank you very much for joining in. You can find us on our website. Let me put it up. galeracluster.com, and we also have a fairly active discussion group on Google Groups where you can send any questions that you may have. And thanks again for joining, and I hope you give Galera Cluster a try, and I hope it works out for your particular use case. Goodbye.
Thank you. Bye-bye.